Okay, here we are in the one of the most fundamental parts of river processing, Livecad. And although I'm hesitating to go into too much detail here, it's going to get long and boring. You'll lose the will to live. And we're going to just have a quick look at an overview, if you like, of what's going on in here. And we are going into the first set. We're still using the Tiverton one, but look what's happened at the beginning. Apart from that EACSD note that came up, we'll cover that in a minute. It checks all the file headers are okay, there's no section numbering errors, there's no structure numbering errors, and it lists all the structure numbers and whether there's a D or a U, or whether they're on one or two cases. There may well be, there we are, number 1 on the third river, there's only an upstream. And there's some notes there, and any errors are shown in the reports area. That's fundamental. It will also tell you if you've got a double number. I did that the other day. I copied a file and stuck in two 1.24 cross-section numbers. There were two. Hadn't noticed it, hadn't deleted the old one, and then wondered why everything went pear-shaped. We now can check for that. It does check, and it will tell you if you've got two numbered of the same numbered CS cross-section numbers, it will warn you. Okay, here we are. We've developed this whole thing that it should be. It's not a CAD system. It is called a Livecad. Anything you touch in this area, in terms of the coded points, is highlighted by a magenta circle. But it also shows you all the headers. And we got fed up with the difficulties of propensity to mess the numbering up. If you want to go and edit in this here, you can. And we'll do this, so I can go in, you can see the cursor moving. But to stop that happening and getting the numbers wrong and the commas wrong, which was always a terribly easy thing, we now put this little yellow box down the bottom so you can individually edit the code, the offset, the level, the dimensions, and the surface and vegetation code, easting and northing. One interesting thing about the surface and vegetation code is you don't have to put the asterisks in there. If you wanted to put, say, STNO, NO, and press STNO, press enter, it automatically does that. So don't waste time messing around with asterisks. That's a function. It had to be separated. We had to find a way of separating the comments area off. There's a comment there of the dimensions of the bridge length, for example. So the only way we could think of was to put asterisks. So anything before the asterisk in that line, then it would be treated as a comment, and you could put whatever you want in there. But it's really quite exciting because for the first time ever we could link the database with the drawing. So if you want to move things around, and I'm not going to go too much on that, it is as robust as we can make it. Sometimes it does go wrong and you just got to go back out, check the data, and if necessary come in from a backup. If you want to find a backup, there, you can always select a backup file here, and it's from the start of the session or day dates and so on. And that was really, so you can rely on this. If anything's gone wrong, you can always go back in and start a backup file. So the main issue was, or the main practical aspect, is to link this here with the map, the plan, the section here. And it's very straightforward. So for example, if I wanted to create a new left bank point, I'll pick it down stupidly in the middle of the river. There it is. And if we zoom in there, we'll find that the BK is now on this point here, and everything has been automatically calculated. So you can see it there. You don't want it in the river. I'm going to undo that, and it'll go back to the top of the wall where it should be. I'm doing a top left, bottom right diagonal to zoom in there. There's your bank point. It highlights the code as well as you put the cursor over it, and it's designed to, if you want to modify stuff on the elevation, it will change in here. So the other thing, oh, here we go, we can just measure a point if you want to know between there and there. Let's try again. Sometimes they have to be picked again. It's not foolproof, but it does mean that you can do this pretty easily. Right, there we are. There we go. And what it's doing is produced a distance between the points, the vertical distance, the slope distance, and a skew angle minimum distance. I've shown this because we got so fed up of having to calculate a skew angle. The skew angle is the bridge alignment or the structure alignment compared to a perpendicular offset from the river at that point. Now, it's made easier if you have an internal minimum distance for if you've been inside the structure between the the central opening between those uprights with your disto, and you've got a vertical minimum distance across the watercourse, especially if the structure is skewed, you could end up with being a meter less and the internal measurement compared to the face measurement. And we'll look at those codes at another time. But the point is, if you then say, I've got this this calculation here, and if I insert a minimum distance for the measured points, it will immediately calculate in this box here the angle that it's got to have. You can then copy it, copy in the clipboard, and it will then you can put it into the structure angle here, and the structure will then be skewed. It won't be skewed on the elevation here, but it will be skewed, and it won't be skewed in the data. And all these distances remain the same, but what it will do when it's exported to a modeling file, the structure is foreshortened, and it's also drawn foreshortened as well. So amazing things can happen there. What I can do is to very briefly show you what the editing help is, and everything you want to know about this here, about this Livecad's operation is here. All the numbered files, if you like, for the help settings are there, and they're accessible, easily accessible. I've told you about the little yellow boxes there. I'm really interested in we can adjust the data bed profile to the structure. If you've resurveyed this structure 10 years later, we've still got the structure data, but the bed has changed. You can simply remeasure on site your bed data, but at the same time take a couple of points that you can then utilize and say this structure is you can create say a lock point. Okay, that's a lock point there, and then you can put a common lock point of what you've surveyed, and it will then adjust the cross section to suit. Equally, if we want to look at the weir, and this was quite an exciting one, we introduced weirs into the view here. So here's your main cross section in the middle center, and down below is the mini weir long section of the LSS codes, which will be shown in here, and even that is live. And so that's a really important thing. But if you'd for example, if you zoom on, if you'd surveyed that from top to bottom, or you couldn't go bottom upwards, which would be from this point here up to the top, then you can always reverse that information and just go like that. It simply reverses the weir, and it goes off to the side, but it basically recalculates the data. And so again, you can adjust that. I really wanted to show you that. Let's just go back to all these icons. Rather than going through what each icon does, simply you can look at how to navigate, how to negotiate, zoom all, pan view, select point, and then the single line editor the full section text editor there simply allows you to go in, and if you want to delete chunks, not a good idea. I'm going to undo that, hopefully. Oh no, it doesn't like that. I've really messed that up now, haven't I? Okay, let's just say that possible critical error. Now, if I'd done that, what I'm going to do is I'm now going to exit, and I'm going to come back in, and I've really done a boo-boo there, and I'm going to come back in, and I'm going to pick the backup file, which is quite important to go back to. If I shut that down, go back to my backup, and it would be the one that was done 235, and I'm going to look at this here, go into that, pick that backup file, replace it, and hopefully when I come back into coming back up onto that weir on section 5, there we are, it's back to what it should be. There we are, completely unintended demonstration of the flexibility of the system. And I wanted to show you also as well, I know you can see in this area in the middle, I can choose the watercourse. If you've got a lot of data, this is brilliant. The other thing you have to remember is this yellow box area is an area where things will crop up. It's quite possible there's none here, but there is here this. It's recognized, the software on this section, if you look on the left, there's a pipe code. And in order to get pipe code as part of structures and to be able to calculate the structure width tables, which are underneath the soffit of the pipe and down to the bed, we introduced this, and it's something that says, look, you've got to watch out what you're doing, but we need you to insert. We've got the top of pipe code. Now in this case, I've already done this. Let's zoom in a bit. I've copied parallel the pipe code, and here's the copy parallel item here. I'm not going to actually do it, so I can select a point on the line to be offset from. So I'm selecting a point on the top of pipe, and then say here was the pipe, it's actually a 225, drop it down, and I'm putting then in effect another line underneath. Now that's important because I need to change that line. It'll copy parallel the PE code, but I've changed this to a BES and a BEN, and then inserted or made sure that the line locks in to the bank. And the way I do that is to go to this one here, select the first point to be extended or trimmed, and I can then touch that point there, and I can insert a point on the polyline. That's useful, and it's done it. That's really important if you want to tie any part of a structure, not just the pipe, a vertical buttress, and you want to place it at that point junction down onto the bed profile. That's really critical for when you're creating the structure width tables, which will create horizontal lines trimmed off to the bed profile underneath the soffit of the pipe down to the lowest point on the bed down there, say, and then at 100 meter interval it'll calculate, copy parallel lines up mathematically, work out the lengths, and on any number of openings, we've had up to 10 or 15 openings, and it creates the little listing of CSV tables that are used in the structure width calculations for the modelers. That saves hours and hours and hours. So we've had a look at some of the icons, and we've got the help files up there. I could view a DXF plan if I wanted to. Yes, so we won't worry about DXF plans, but we can look at photographs, and these photographs can be made bigger. So that's this bottom section 101. It's looking back using the DAT file, using this numbering 101, looking at the 101 photographs in the photograph subdirectory. And by using a space bar, you can then just go through purely for the cross sections on the photographs on that cross section. That's a really useful thing. We can hide the error list if we want. I was going to look and see whether we've got anything in this yellow area. Because this has been made so pretty perfect, anything in the yellow area are items requiring checking. And if you click on the yellow area, it's linked to this side. The blues are really items to be reviewed, the recommendations and that sort of thing. The watercourses are all there, and we can cancel the operations that you're working on. Dimensions format. This is going to be a really complicated one for some people who are coming into this cold. But in here are all the codes, and you'll notice there, you just want to see that, there is your surface and vegetation code. The surface CC is concrete. In this case, there is nothing there, so we see NO. Interestingly, though, if you're out in the middle of the river, don't keep typing NO. If you're on a water, just put CO for cobble, don't put anything else. The NO is automatically added when you come back in and import all the data. So if you're missing a vegetation code, if there isn't anything there, the system will assume that it actually is an NO code, which means there's nothing there, except if you've got free floating weeds, and I forget what the code that is, but that would be used on site. So it's that important bit there, which is there, and to the left is the height of the fence. It's an FEX code, and so we've got a suffix of T, W, or S for wire or steel, and it says the 1200, it must be the value in the fourth field before the SOGS value. We got the BRX. Now you can take 2 points on side with a BR code. So you would have, if you're on, say, we know that the first section 101 is a structure on this project, then you would put it in BR 101. If you just take 1 point on the site and use a distance measurement, put it in your remark 6360, it will utilize that. But you could take 2 points and on a BR code, and this is where it says it here, and it will automatically reduce, it'll work out the length of the line between those 2 points, and then it gets added in automatically. We've got the pipe code there. Yeah, this is the water level code, time example at the top. The outfalls, don't forget the CTX is a structure code in line with the watercourse, where the water flows through. Yes, I know you get water coming out of outfalls, but the outfalls are separate. You might have simply, what do you call it, drains, road drains coming off a road and coming in through the bank or the wing wall of the structure, and that's just an OF. The CTX code tells the system this is important, this is a culvert, we know the diameter, and that is used in the long, it's assuming that it is a structure item as if it was a bridge or a culvert, and that is then drawn in a hatched green setting on the long section. In other words, it's a complete structure that has an upstream or a downstream or just an upstream face only, and it then gets treated very differently, and it's put in with the whole of the system on and outfalled out as a it's exported as an item. But the CTX, so the OFX, is purely a pipe that happens to be near the structure, could be on the structure, could be coming in through underneath the structure, and if you want to, you just call it OF 105 or whatever it is, and so that's it. That will then connect that outfall with the structure, and you can have a rectangular one there as well. Circular outfalls are plotted as if they were ellipses in the elevation, and you can put the rectangular 500 by 900 and so on. We use TR for a trash rack, and normally you'd take 4 or 5 points to create a TRS outline where the It's not going to plot on the drawing the actual bars, but it will make a simulation of that. But it will put some text there saying this is a trash rack, and there are 16 bars, 11 millimeters diameter, and that is really a requirement of the environment HE that needs all this. If you've got an outfall along the watercourse, then you're going to be collecting these in the same way, but coding them differently, because the outfalls and the banks and the walls need to be related to the river and not to a cross section. So here, as it shows here, you would have OF100 is a circular or rectangular outfall. It's not used in the DAT file. It's now recorded and kept separately, so that you would have there a TB100 top of bank on River 1, OF outfall. There would be in the remarks there a 750 size in millimeters, and then a wall 100. And the software, this is the clever bit, the software will sort the left or right side of the watercourse and also eventually change this data if required. Huge amounts of stuff going on in the background there. That's why, but this help file, don't assume you know it. If you're not sure, try and find out and decide what you should be doing. Because once you've gone through from this area, you want to make sure your DAT file's perfect. So when the outputs, the drawings and the exports are done, you don't have any problem. You don't want to be, otherwise you're going to have to come back into this area, put the data right and re-export everything. And that's not something that you really want to go through. Everything you ever need is in this list up here as well. What's that one there? Open current folder. Yeah, that will just go open up the current data files folder for the project which you're on. So I don't want to go any more on about this stuff because all the data is in here. I can set options, can I? There might have been options once, you might have changed that. But here we are. This is the one to look at, the main Livecad help. It's all there, and I wish you well in sorting this all out. Brilliant. Bye now.